Hi guys, today we're going to look a little bit more at radians. Now in the last subject, what I did with you is I just got you to convert between degrees and radians and vice versa. And I said that for radians, one full rotation is 2 pi. But aside from that, I didn't really dig into what radians actually are, why we use them, and what's going on there. So this is going to be a bit of a theory lesson to help you understand what radians are. So let's start by looking at a circle. Now this thing here is called a unit circle, right? It's a circle that has got radius 1. So if we talk about a unit circle, it's a circle of radius 1. Now what I want you to imagine is we take that radius and we create a little arc there, right? So we go through an angle here. That angle we're going to define as theta. For those of you who have never seen that before, theta is a Greek letter. It's pronounced Theta, theta, and that defines the angle. And so we've got the angle there, which is theta. Now, as we go through that angle of theta, what we do is we subtend an arc. Right? Subtend's a name which means you just go through an arc. And we're going to define that arc there as S. Right? So we've got an arc length S. And what we're going to say is that for radians, whatever is the length of our arc is our angle in radians. So if we have a unit circle, right? So if we have a unit circle, which means that the radius is 1, then the angle in radians is just equal to the arc length. Right? The angle in radians is just equal to the arc length. So if you imagine this, let's say that we've got an arc length here, and this arc length just so happens to be, let's say it is equal to 2.1. Okay, that's 2.1 there. Well, then what's this angle going to be in radians? Well, that angle in radians is going to be 2.1. Okay, because it's a circle of radius 1, the arc length subtended is 2.1, and so the angle in radians is 2.1. Do another example. Let's say we go through this angle here, right? We don't know what that angle is, but this arc length here, right? That arc length there, all of that, let's say that arc length is equal to 3.05, right? Just choosing a number at random. Well, if that arc length is 3.05, then the angle in radians is 3.05, okay? So then, what is 1 radian? What is 1 radian? Well, we could think of it as, well, we got our unit circle here, circle radius 1. What is 1 radian here? It's the angle that will create an arc length of size 1. Right? The angle that will create an arc length of size 1. Or if you prefer, you could actually think of it in a slightly different way. You could think it, let's say I've got any radius, so it doesn't have to be radius 1 in this case, I've got any radius there, radius r. An angle of radians 1 will produce an arc length of the same size as the radius. Okay, so two slightly different ways for you to think about it. Now let's go back and consider a circle. Okay, so here's a circle here. It is a circle again of radius 1. And imagine that we were to rotate this circle all the way through one full rotation, right? So we're going through one full rotation, and that's an angle there of theta radians. Now, what would that angle be? Well, it would be equal, wouldn't it, to this arc length here, right? One full arc length. But we know that that arc length there is just the circumference of a circle, and we know that the circumference of a circle is equal to 2 pi r, right? That's the definition of the circumference. So if our radius is equal to 1, then our circumference, in this case is just our arc length, is equal to 2 pi. So if our arc length there is 2 pi, then what is our angle that we've got? Well, that angle must also be 2 pi. So for one full rotation in radians, we know that the angle must be 2 pi, because for radians, the angle is always equal to the arc length that has been subtended. And so if we go through one full rotation, we know that that arc length must be equal to 2 pi. And so therefore, the angle will be the same as the arc length. It will be equal to 2 pi. Well, okay. Well, I think then lastly, what might be helpful for those of you who needed something a little bit more visual, I'm going to show you a clip that's taken from a Wikipedia page. And hopefully that this will get you to see things a bit more clearly. So let's have a look at that. So here we've got a radius r mapping out a circle. We're going to take that radius, right, same radius r, and we're going to produce an arc length of size r. Well, if that's the case, then the angle is going to be 1 radian. It's the same as the radius. And so 2 radians will be double that arc length, and 3 radians will be triple the arc length. And as we go around one full circle, we would get to 2 pi radians. Half a circle is 1 pi, one full circle is 2 pi. Okay? I hope that helps you out. For those of you who are struggling with sort of the theory and visualizing things, in many ways, it doesn't matter so much. You can try to just keep using the formulas, but I would strongly encourage you to get an idea. What does a radian actually mean? It is important because radians, unlike degrees, they're mapped to real-world physical properties, the properties of a circle, and therefore that's why they are applicable in more advanced mathematics. Okay? All right, I hope that's been helpful, guys. I will see you again next time.